All right, here we go. Let's finish up our notes from earlier today. We finished up talking about the chain rule. We got through example 2. We talked about how it's the derivative of the outside at the inside times the derivative of the inside. We saw a nice example here. It's pretty obvious that this is like a u to the 15. Not obvious, but u to the 15. We do our usual, which is bring the 15 down, u to the 14th. We don't change the stuff here. But the new thing is we now have to multiply by the derivative of the inside. So let's go ahead and turn the page and get right into our example 3. So example 3 looks like this. It's got g of x equals x cubed minus 9x, not too bad, to the 300. Oh man, can we handle that? Of course we can. This is not really a big deal with the chain rule. So we'll pretend like that's u to the 300. So the 300 comes down, u to the 299, also known as 300 minus 1. See if I can adjust the brightness there. That looks a little bit better. All right, and then we don't change the stuff. If this is u to the 300, this is 300u to the 299. U did not change. Don't change. You're perfect the way you are. All right, let's go multiply by the derivative of the inside. That would be 3x squared minus 9. And technically, you're done. You might see it in a different form. They might take this binomial with the smaller power and put it in front of this binomial with a much bigger power. But really, it doesn't make that big of a difference which way you write that. Either way is fine. And I think that's good. Okay, so next up, example 4. Of course, when you're watching a video, to fix this up, feel free to pause it at any time and go finish up whatever you didn't finish yet. Next up, y equals 4 cosine of x to the third, and they ask for dy dx, which we know is another name for derivative. I forgot, on the last example, we should have said g prime of x equals what? That's what they asked for. So derivative, slope of the tangent line. Here goes. dy dx. So we need to figure out which function's inside, which one's outside. If you read this, it says 4 cosine of x to the third. That means x to the third is the inside. So the outside function is 4 cosine of stuff. So what's the derivative of 4 cosine of stuff? That would be negative 4 sine of stuff. And we don't change the stuff. So this is the derivative of the outside at the inside times the derivative of the inside. That would be times 3x squared. And this piece right here, this is the derivative of the inside x cubed. So let's rewrite that one more time. We'll bring the 3 out here to negative 4, join those coefficients, get the algebra to come next, and then we'll go back to the trig. That's just kind of the convention that we follow. Coefficients together up front, algebra next if you got some, then some trig after that. And there's the end of example 4. All right, this next one, I think we might need a rewrite. So you could do quotient rule, right? We know how to do quotient rule at this point. That wouldn't be too terribly difficult. But we can also rewrite this as 4x minus 3 to the negative 1. And now, when I go take a derivative, y prime, we'll start with our power, because that's the outside function. That'll come down. Take the stuff to 1 power less, and then go multiply by the derivative of the stuff inside. So again, derivative of the outside at the inside, that didn't change, times the derivative of the inside. So this one's an okay answer. If somebody didn't want to leave the negative exponent, they might move that to the bottom. And that leaves a negative 1 times 4 on the top, which is negative 4. And then we could just box that up. Remember, when you move that power down, you got to change the sign. If you leave that as a negative 2, then somebody might look at that and go, hey, move it up there. And if it stays negative, the next person will say, no, move it down there. So when it changes sides, it's got to change signs. When it changes sides, it has to change signs as well. All right, 2 more. One more fairly quick one, and then we've got kind of a tougher one to end the notes. So f of x equals the square root of 2x minus 7. We want to know what f prime of x is. So first thing we'll do is just a rewrite, 2x minus 7 to the 1/2. Notice there's no negative power like on the last one, because we didn't bring something back up to the top. It was already on the top. We just changed the root into a fractional or rational power. So to find the derivative, it's u to the 1/2, so we'll go 1/2 u to the negative 1/2. Again, reducing by 1. Subtract 2 halves and you get a negative 1/2. So then you got your stuff, which doesn't change, and then you got the derivative of the stuff out at the back. All right, so the 1/2 and the 2, those actually cancel each other out. So you're left with 1 over, that's the negative part, move it back down to the bottom. The 1/2 makes it a square root. We've seen that kind of thing before. So there you have it, 1 over the square root of 2x minus 7. That got a little sloppy there. Let me clean that up a little bit. There we go. Remember, that's the slope of the tangent line. So you've got this function. If you could graph this function, we can go to any x value now and tell you the steepness or the slope of the tangent line at that location by plugging into here. All right, the last one. This one, a little bit more complicated. Cosecant of, just kidding, cosecant squared of 5x to the 4th. Cosecant squared of 5x to the 4th. And of course, we're looking for a derivative. And I have a question for you before we start it. How many functions are nested together here? And one way of doing this is think about plugging in. If you plugged in a number, say 1, would you take the cosecant of 1? Would you square the 1? Would you take 1 and multiply by 5? Or would you take the 1 and take it to the 4th? And I'm hoping you said put it here, take it to the 4th. After that, square it? No. Multiply by 5? Yes. Plug in the 1, take it to the 4th, multiply by 5. Don't square it yet. Take the cosecant of whatever that was and then square that. So the outside function is actually a squared thing. Let's write it like so. Take the squared, put it outside. And a little note for you. Sine squared of x is sine of x quantity squared. Okay. Sine squared of x is not the same as sine of x squared. Okay. So let's go ahead and get started. So g prime of x, we're going to take our u to the 2nd. That'll become a 2u to the 1st. And we don't change the u, don't change the stuff. Times the derivative of the inside. The inside was the cosecant of 5x to the 4th. So at this point, we're just going to write that out as a derivative process that's going to happen. We're not going to actually do the derivative just yet. I want to see how this builds. So derivative of the outside at the inside times the derivative of the inside. Next, we can copy this down. We don't really need the brackets anymore, but we use parentheses around the 5x to the 4th. The brackets don't do anything because it's just a power of 1. So then we need the derivative of the next outside function. So if you just focus on this, which one's the outside? I think it's pretty clear that's the inside, so this must be the outside. So the derivative of cosecant, it's a negative repeater. It's a negative cosecant of stuff times cotangent of stuff. And the stuff has not changed. It's still 5x to the 4th. Times the derivative of its stuff on its inside. Okay, we're almost there. 2 cosecant of 5x to the 4th times negative cosecant of 5x to the fourth. And I know some of you are thinking, couldn't we put some of that together? The answer is yes. I just thought I would leave that for later. All right, we need the derivative of 5x to the fourth. That's a simple one, 20x to the third. So now we're going to take the 2 and the negative 1 and the 20x cubed, put them together, get ourselves a negative 40x cubed. Now we had a, oh boy, I just found a mistake here. That should not say cosine. Hopefully you caught that. That should say cosecant. I was just copying down and I copied it wrong. My bad. Can I get an it's cool? Thank you. Did you hear that? My computer went ding dong right when I asked for an it's cool. So thank you for that message. I appreciate that, guys. Cosecant times cosecant is cosecant squared 5x to the fourth. And then we have a cotangent 5x to the fourth. And I think we're done. We had a cosecant times a cosecant. The negative already came out to the front. Cosecant times cosecant is cosecant squared. And we got your cotangent. And we already took the 20 to put it with the 2 and the negative. We already have the x cubed. We are done. That's that. All right, that's a big long process. It gets quite crazy sometimes. And that's only with 3. Imagine if we had 4. All right, I'm going to go ahead and move this to the side and show you the homework assignment, which is at the bottom of these notes, which is the same thing. So thank you for finishing your notes. Go back and review some more if you need to. Taking your time to get through them. Make sure it makes sense to you. If you have questions, as always, you know, you can let me know, and I will get back to you quickly. So here you go. You got some trig to do, and then you got some chain rule to do. All right. Thanks for watching. We'll see you next time.